I'm Anil Kumar, and in this video we will discuss transformation of absolute functions in details. The question here is, explain the steps and sketch graph of g of x equals to minus 2 times absolute value of half x plus 1 plus 1. You may pause the video, copy the question, sketch the graph, and then compare the answers. Now, whenever you are given a function like this, it is important to factor the coefficient of x. So let's do that to begin with. So we can write the function g of x as equal to minus 2 times absolute value factor half. You get x plus 2, right? X plus 2 plus 1. It is a good idea to check. When you expand, half x plus half times 2 is 1. You get exactly the same thing, right? So that becomes the transformed function. And from here, you can actually describe the transformations. So let's describe the transformations one by one. So what we'll do is we'll begin from the left side and move on towards the right so that we describe each one of them in proper order. So minus here means reflection on x-axis. So it is reflection on x-axis. I'm writing them in short form. You should actually write it in full form. 2 means vertical stretch by factor of 2. It is important to write factor. That means it is getting multiplied by half. It is inside this absolute function. So that represents horizontal because it is inside, and it is half. It becomes stretched by a factor of 2. So it is horizontal stretch by factor of 2. And then we can write down the translations. Let's combine both translations. Horizontal, it is 2 units to left, right, and 1 unit up vertical. So I can write in short form 2 units left and 1 right. So these are the transformations which the parent function, absolute function, should go through to get the graph for the transformed g of x function. Okay. So we have described the transformations. Now what we will do is we'll also describe how the points get transformed. That is, if there is a point coordinate xy in general on absolute x, then on g of x, what happens? As far as x is concerned, horizontally stretched by a factor of 2, that means it gets multiplied by 2. 2 units left means minus 2, right? As far as the y point is concerned, the y coordinate value, reflection on x-axis and vertical stretch by 2, that means multiply y by minus 2. So it is minus 2y, and 1 unit up means plus 1. So that is the transformation as far as points are concerned. Correct. So this is another important criteria. Now we may look into the critical points, or sometimes I call them key points. So let's make those key points here and write down the transformed points. So let us say this is for absolute x, that is f of x, and this is for the image on g of x. In absolute function, good points to take are, let's say these are the points which we are going to consider. Okay, so let me just mark them. Okay, so we'll work with these 5 points. So we have minus 2, 2, minus 1, 1, 0, 0, 1, 1, and 2, 2. So these are the points on the original parent function. Once they get transformed, then we get minus 2 becomes, we have to multiply by 2, so it becomes minus 4, and minus 2 is minus 6, right? So we get minus 6. As far as y is concerned, it becomes minus 4, and minus 4 plus 1 will be minus 3, right? So that will be the y point. Similarly, do all calculations, right? So minus 1, so that gives minus 2, and minus 2 is minus 4. Minus 2 plus 1 is minus 1. 0, 0 will give us minus 2 and 1. 1, 1 will give us 2 minus 2 as 0. And 1 here will give us minus 1, right? For 1, minus 1. For 2, 2 times 2 is 4, 4 minus 2 is 2. Okay, and here minus 4 plus 1 is minus 3. So these are the transform points. So we could actually sketch the transform function directly also. So let's sketch these points. Okay, so 0, 0 comes to minus 2, 1. It makes sense. We are moving 2 units left, 1 unit up. So this 0, 0 goes to minus 2, 1. Let me use another ink to sketch the final graph. So it is minus 2. So let's start with, okay, we can start from here. Since we do not have minus 6, I'm avoiding this point for the time being, but we'll go with the second point, which is minus 4, minus 1. So minus 4, minus 1 is right there. Minus 2, 1. So minus 2, 1 is this point. 0, minus 1. Add 0, we have minus 1. So that is the point. And then we have 2 minus 3, 2, and then minus 3. So these are the points which should be there on the transform function. Let us join them. And similarly on this side, so we get the transformed functions graph using the points, correct? So that is how we could get the transformed function using the coordinate points. Well, this is one method of doing. Now, I will show you how to sketch the transformed function following the basic steps. Okay, so basic steps means that we'll perform these operations one by one. So let's do first the horizontal stretch, as some students need clarification on this. So we'll begin again with the absolute x function, and we'll stretch it horizontally by a factor of 2. It really means that the x values get multiplied by 2. So 1 becomes 1 times 2 as 2. So this point moves to here, right? Here it is at 2. 2 times 2 is 4. It moves to 0.4. 0 remains at 0. So I can connect this. So that becomes 1/2 of my graph horizontally stretched. So this is absolute value of, half x I should write, right? Half x. Yeah, half x, correct. Similarly, on this side, minus 1 times 2 is minus 2, minus 2 times 2 is minus 4. So we can connect these points. 0 times minus 2 is 0, so the origin is invariant. Invariant means that it remains at the same spot, right? Does not change. So what we've done is, we have done this part, correct? Now, we'll incorporate vertical stretch along with reflection, these two steps. That is to say, multiply the y values this time by minus 2. 0 times minus 2 is 0, so it remains there. The second point is at 1. 1 times minus 2 is minus 2, so we get a point here, correct? 4 times, this is 2. 2 times minus 2 is minus 4, so this point gets reflected, and we'll get it right there at minus 4. Now on the left side, 1 times minus 2 is minus 2, and Okay, and sorry, this was this minus 2, and here we have somewhere 2, which is at minus 4, correct. Joining these, we get the vertical stretch part, vertical stretch by 2, and reflection on x-axis, right? So this is the graph which you get. So what I've done here is, okay, yes, this is 1, 2, 3. This point is wrong. This should be here, right? So, okay, so that is it. Perfect. So, second graph is incorporating reflection and this factor, and I could write this as minus 2 times half of x, correct? Now finally, we'll sketch the final function from here, incorporating the translations, right? So this is the step. 2 left, 1 right. So let's begin from this step at the origin itself. So we'll do the left part first. 2 left, so that means 1, 2, and 1 right. So you reach here. Do you see that? Now again, 1, 2, and 1 up, you reach at that point. So we are landing on the same final graph which we did from the coordinate points, image points, right? On the right side, we have to go 2 left, 1 up. So we go 1, 2, and 1 up, right? So it is like 1, 2, and 1 up. So we reach at the same place. Here again, 2 left and 1 up, right? So do you see? Finally, we again get the same function, which is g of x. So we get g of x exactly same as we did in the first, which is obvious. We should get it. Anyway, so you understand now how to sketch transformed functions using 2 different methods. One, using image points. So here we used image points, right? And the second method was using steps. So step number 1 for us was to do horizontal stretch by a factor of 2. Step number 2 was to do vertical stretch and reflection. And step number 3 was to incorporate translations, which were 2 units left and 1 right. So you could adopt any of these methods to sketch absolute functions. I'm Anil Kumar, and I hope you got the gist of sketching transformed functions from this video. So the idea here is, let me summarize. Whenever you are given a function, have a good look at it. It may require factoring of coefficient of x, as we did. Once you factor, you see horizontal translation, right? You can read it now correctly. You should write the transformations in order. I prefer to write from left to right. Now there are 2 methods. One is using the image points. The other one is using the steps, right? So this is our method number 2, and this is our method number 1. For image points, we see that xy coordinates get transformed to 2x minus 2, that is 2x minus 2, and y points will be multiplied by minus 2, y plus 1. So take the key points. These are the key points for any absolute function, okay? Consider the key points, write down the transformed points, connect them to get your final graph. In following the steps, you should do first multiplication type of steps, which incorporates stretches, compressions, and reflection. I did it with horizontal stretch. You could start with vertical, reflection, and stretch, right? So 1, 2, and the last step should be translations. You will see that either method you adopt, you should land with the correct solution, as we did in this particular case. I hope that helps. Thank you, and all the best.